Hello everyone, good morning. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium, and in this session we are going to learn about characteristics of equilibrium constant. Let's start the session. Right. So we are discussing about characteristics of equilibrium constant. Already we have studied that equilibrium constant. So K equilibrium, it can be Kc or Kp. Okay, already we have studied that equilibrium constants can be expressed as Kc or Kp. What is Kc? Equilibrium constant with respect to concentration of reactants or concentration of products. Kp means equilibrium constant when the reactants and products are represented by their partial pressures. Right? This already we have discussed in the previous lecture. Now we are speaking about what are the characteristics of this equilibrium constant. Right? Let us see. So equilibrium constant is applicable only when concentrations of the reactants and products have attained constant value. Already we have studied that at equilibrium, the concentrations of reactants, the concentration of the products remain constant. When they are remaining constant, then only this equilibrium constant is applicable. Okay. Now let us see the value. This is important. The value of equilibrium constant. So K will have some value. K is having some value. That value, whatever it is, 10, 15, 20, 25, whatever it is, the value of equilibrium constant does not depend on independent. So this point is very much important. Okay. This can be asked in the form of statements. So K, value of K. What is that? Value of K. K means equilibrium constant. E does not depend on. One. What is that? Initial concentrations. Initial concentration of reactants and products. Right? Initial concentration of reactants and products. The value of K does not depend upon initial concentration of reactants and initial concentration of products. Okay. The second one. It does not depend upon the pressure. Okay. Third one, it does not depend upon the catalyst used in the reaction. Okay. And it does not depend upon the volume of the vessel in which the reaction is happening. So it does not depend upon volume of the vessel in which the reaction is happening. These four things we need to remember. So value of equilibrium constant does not depend upon initial concentration of reactants and initial concentration of products. It does not depend upon the pressure of the reaction. It does not depend upon the catalyst used for the reaction, and it does not depend upon the volume of the vessel in which the reaction is happening. Okay. And on what this value of equilibrium constant depends on? On what it depends on? Let us see. Equilibrium constant, the value of equilibrium constant depends on temperature of the reaction, or the temperature at which the reaction is happening. Next is mode of writing the equation. We will discuss this in detail. On what factors does this the equilibrium constant is depending upon? One is temperature, the next one is mode of writing the equation, and the third one is stoichiometric coefficients. See, whenever we balance an equation, before the reactants and before the products, we write some numbers, and those are called as what? Stoichiometric coefficients. So the value of equilibrium constant depends upon the stoichiometric coefficients in a balanced equation. Okay. So first one, let us see variation of equilibrium constant with the temperature. Already we have studied that equilibrium constant, the value of equilibrium constant depends on temperature at which the reaction is happening. So how does this equilibrium constant, the value of equilibrium constant varies with the temperature? Let us see that. Actually, we are deriving a formula. We are deriving a formula to find how the value of equilibrium constant or equilibrium constant varies with the temperature. Okay. We are deriving a formula. So let us derive the formula. And what is that formula? The formula is log K2 by K1 is equal to delta H by 2.303 R into T2 minus T1 by T1 into T2. So this is the formula. This formula shows how the equilibrium constant is varying with the temperature. When you change the temperature, how equilibrium constant changes. See here, K2 is equilibrium constant at temperature T1, T2, and K1 is equilibrium constant at temperature T1. See, when you are changing the temperature, equilibrium constant is also changing. So this formula gives you the information about how the equilibrium constant is changing on changing the temperature. Okay. So to derive this, we use Arrhenius equation. Arrhenius has proposed this equation. Actually, this equation we study in detail when we study chemical kinetics. So chemical kinetics is a physical chemistry chapter which we study in second year actually. In that we very much detailedly discuss about what is Arrhenius equation and details regarding Arrhenius equation. Right? So we are using Arrhenius equation to derive this formula. What formula? The formula which shows how the equilibrium constant is changing on changing the temperature. Right? So let us start the derivation of that formula. Okay. Arrhenius has proposed an equation. Arrhenius equation is given by K is equal to A E power minus EA by RT. This is the equation. Okay. Where what is K actually? K is rate constant. What is this called as a rate constant? What is A? A is called as Arrhenius factor. Arrhenius factor, which we study in our chemical kinetics as frequency factor also. Frequency factor. What is the meaning of frequency factor? And all these we will study in chemical kinetics. Up to then, just we shall remember what are these things. That's it. What is EA? EA means activation energy. What is that? Activation energy. E is exponential factor. What is that? Exponential factor. And R, you know, R is universal gas constant. Gas constant. And what is T? Absolute temperature. Absolute. So these are the terms which are used in Arrhenius equation. So let us take a reversible reaction. What is that? A gives rise to B. Right? So A to B is a forward reaction and B to A is a reverse reaction. Right? So for forward reaction, if you apply this Arrhenius equation, forward reaction. For forward reaction, I am applying. What I am applying? K is equal to A e power minus EA by RT. As it is forward reaction, what I am writing? Kf I am writing. Because K rate constant for forward reaction, because we have taken what reaction? Forward reaction. Okay. Next, EA, F I am writing. Why? Forward reaction, it represents forward reaction. AF I am writing. Why? It is for forward reaction. Right? Let us take a backward reaction. Backward reaction. So backward reaction, for backward reaction, what do I write? KB is equal to, right? AB, B represents here backward reaction, E power minus EA backward reaction by RT. Okay. So what did we write? We have written Arrhenius equation for forward reaction and Arrhenius equation for backward reaction. Then K equilibrium. What do I write? K equilibrium. K equilibrium can be written as K equilibrium is equal to, already we have studied that it is Kf by Kb. The ratio of rate constant for forward reaction to rate constant for backward reaction is called as what? Equilibrium constant. Right? So then I can divide this. Kf, what did I write? AF into, simply divide it, then what do you get? Let us see that. What do we get? AF by Kf by Kb. So AF by AB into E power. So both are power E. When this denominator minus EAB by RT moves up, what do you get? Plus EAB by RT minus EAF by RT. Okay, so here BF represents that forward reaction and backward reaction, right? So let us see. Then if I take a common AF by AB into E power 1 by RT into EAB backward reaction minus EAF forward reaction. So this is what K equilibrium. K equilibrium. That is equilibrium constant. So now what we have derived? Formula for equilibrium constant by using Arrhenius equation. Okay. So now at two different temperatures we shall discuss. At temperature T1, right? Let us discuss at temperature T1. Temperature T1. Then what you write? K1, equilibrium constant. K1 is equal to AF by AB into, right? Simply I can write EAB minus EAF by RT1. Universal gas constant does not change. Okay, so at temperature T2, what we are writing? At temperature T2, K2 is equal to AF by AB into E power minus EAC plus EAB minus EAF. Same equation we are writing, but the temperature is changed. Only what is changed? Temperature is changed, right? So what is this K1? K1 is equilibrium constant at temperature T1. What is this K2? Equilibrium constant at temperature T2. Got it? Now let us divide that. Let us divide that. Then what do you get? K2 by K1. First of all, let us write K2 by K1 is equal to AF by AB into E power EAB minus EAF by RT2 by AF by AB into E power EAB minus EAF by RT1. Okay, let me cancel this. Then what do I get? K2 by K1, I am getting it as E power. Both are E, so power. I am writing it as, right? So EAB minus EAF, if I take common by R, then what do I get? 1 by T2 minus 1 by T1. This goes up. Okay. The denominator E power goes up. Then if it goes up, it becomes minus. Both our powers are, this bases are same. What is the base? E. Okay. So now we got this equation. Let us derive the remaining part. What did we get? K2 by K1 is equal to E power EAB minus EAF by R into T1 by T2 minus 1 by T1. That is what we got. Is it right? Is it that? Yes, we got that. Now apply logarithm to this. Let us apply logarithm. So natural log is represented by ln. Let us write ln log K2 by K1 is equal to log e power x is equal to x log e. We know that log e power x is equal to x log e. Directly I can write it as EAB minus EAF by into 1 by T2 minus 1 by T1, because natural log e power e is equal to 1. Okay, so this e and both e's are same. I am writing in a different way, but both are same. Are you getting this? Okay. Now let us see that. By R we have. See here on the right side, I am mentioning that it is 1 by T2 minus 1 by T1. If I write EAF front and EAB minus by R, then I can write it as 1 by T1 minus 1 by T2, right? If I move T1 in this way, then automatically you get minus. Minus of minus gives you this possibility. Okay. Very small change. Are you observing it carefully? Can you observe it? Initially it is 1 by T2 minus 1 by T1. In the next step, what did I write? 1 by T1 minus 1 by T2. Following? Are you following? Right? Then what I get? Log K2 by K1 is equal to, see, we know that delta H is equal to EA forward reaction minus EA backward reaction. Okay, we have from chemical kinetics we can say, or not only from chemical kinetics, from thermodynamics also we can understand that change in the enthalpy is given by, for a reversible reaction, activation energy of forward reaction minus activation energy of backward reaction. This difference in the activation energy gives you change in the enthalpy. So I can write here delta H, because EA forward reaction minus EA backward reaction gives you delta H by R into, if I take T1 into T2, T2 minus T1, right? If I convert this natural log into log base 10, then I can write it as 2.303 log K2 by K1 is equal to delta H by R into T2 minus T1 by T1 into T2. If I move this 2.303 on the right side, it comes to the denominator position, right? Are you following? Right? Log K2 by K1 is equal to delta H by 2.303 R. Okay. R into T2 minus T1 by T1 into T2. Oh, finally we got the formula. Super. Okay. Got it. So this formula shows how the equilibrium constant changes with the temperature. See, at temperature T1, equilibrium constant is K1. At temperature T2, equilibrium constant is T2. So in the examination, we are asked in JEE Mains or JEE Advanced, we are asked questions based on this formula. Why we have derived it, you may be having doubt how this formula has come. That is the reason why we have derived it. Okay. So let us see how question can be asked. There are different statement type of questions as well as mathematical numerical value questions asked on this formula, right? Let us see. So this is all derivation. These are some steps given. I clearly derived it. Okay, let us see. So the dependence of equilibrium constant on temperature is given by, this equation is also called as Van 't Hoff equation. What is that Van 't Hoff equation? Log K2 by K1 is equal to delta H by 2.303 R into T2 minus T1 by T1 into T2. Okay. So this formula is important. These two statements are also very much important. Why? because these two statements are asked in the statement type question. Statement 1, statement 2, statement 1 and 2 are correct, and statement 1 is wrong and statement 2 is correct. In that way, questions can be framed. There are some PYQs also on this particular statements. See, let us see what is the meaning of these statements. Let us write the equation. What is that equation? Log K2 by K1 is equal to delta H by 2.303 R T2 minus T1 by T1 into T2. So this is the equation showing the relation between equilibrium constant and temperature, right? Now, exothermic reaction, let us take exothermic reaction. Exothermic reaction. Exothermic reaction means already we know that delta H is negative. Okay. Delta H is negative. Then on increasing temperature, let us take on increasing temperature. On increasing temperature. That means T1 is greater or T2 is greater? Temperature is increased from T1 to T2. And moving from T1 to T2, temperature has been increased. Then what we can write? T2 is greater than T1. Right? If T2 is greater than T1, then I write T2 minus T1 will be what? Positive. Right? T1 minus T2 will be positive. Now let us write this. Log K2 by K1 is equal to delta H is negative, no? So negative by 2.303 R, okay, into positive by T1 into T2. Why I have written positive there? Because T2 is greater than T1. T2 minus T1 will be automatically positive, right? Okay. Then what do you get? Log K2 by K1. Then K2 by K1 will be negative. Negative into positive gives you negative. So log K2 by K1 will be negative. If it is negative, then K1 is greater or K2 is greater? No doubt about it, K1 is greater than K2. That means when you are increasing temperature, K value is decreasing. See, K1 is greater, K2 is smaller. That is what he says in the first statement. What he says, for exothermic reactions, Kc decreases with increasing temperature. We have increased the temperature here, K value decreased. Understood? Is it clear? Okay. See, for exothermic reaction, this statement is important. For exothermic reactions, on decreasing Kc, there is on increasing temperature, there is decrease in the Kc. So we have derived it. The same let us see for endothermic reaction. We know that endothermic reaction. So let us see. Endothermic reaction. Endothermic reaction, delta H is equal to what? Positive. Endothermic reaction, delta H is equal to positive. On increasing temperature, let us see. Increasing temperature means T2 greater than T1. That means T2 minus T1 will be positive. Okay, let us substitute this in that equation. On substituting, then what do you get? Log K2 by K1 is equal to delta H positive, no? What is that? Delta H positive. Positive by 2. 2.303 R into T2 minus T1 is also positive. Positive by T1 into T2. Okay, positive into positive gives you positive. Then what do you get? Log K2 by K1 is equal to positive. If it is positive, if log K2 by K1 is positive, then what is the relation between K2 and K1? No doubt about it, K2 will be greater than K1. That means on increasing temperature, K is increasing. K2 is greater than K1 now. On increasing temperature, equilibrium constant is increasing. This is for whom? Endothermic reaction. This is for whom? Endothermic reaction. So for endothermic reaction, on increasing temperature, equilibrium constant increases. For exothermic reaction, on increasing temperature, equilibrium constant decreases. Okay, these 2 points are very important. So that is what the variation of equilibrium constant with the temperature. The next one, let us go with the next one. Mode of writing the equation. Mode of writing the equation. Okay. So equilibrium constant depends upon mode of writing the equation. So let us see here. There is a reaction. A gives rise to B. There is a reaction. A gives rise to B. So what is K for this? K, equilibrium constant. Let me write Kc, which is equal to K. I am writing that is equal to concentration of B by concentration of A. We know that product concentration by reactant concentration is Kc. Then if I change its mode of writing the equation, what did I do? I have written B gives rise to A, not A gives rise to B. Now, will the equilibrium constant remain same or change? Yes, the equilibrium constant changes. The value of equilibrium constant changes. So when you change the mode of writing the equation, what happens? Equilibrium constant changes. That is what we are speaking. Now let us take, so this Kc is equal to K prime. Let us take, I am writing here in this way. That is equal to what? Concentration of A by concentration of B. So what is the relation between K prime and K? K prime and K. So if you want to clearly understand, then let me write it as K1 and K2. It would be better. What is the relation between K2 and K1? See, K2 is A by B, K1 is B by A, reverse. Are you getting this? Then if I see K2 is equal to 1 by K, K1. Will I get this? See, K2, what is K2? Concentration of A by concentration of B. 1 by what is K1? Concentration of B by concentration of A. If you write again, concentration of A by B, you are getting. So, K1 and K2 are not same. Are both same? No. Why? What is the difference? The difference arised because of difference in writing the equation. You have changed the mode of writing the equation. On changing the mode of writing the equation, K value changes. Equilibrium constant changes. That is what we are speaking under the characteristics of equilibrium constant. Okay. So let us solve a question. Here is a question given. Let us solve that. So for this reaction, equilibrium constant is 2 into 10 power minus 2 liter square per mole square. So what is the equation? N2 plus 3H2 gives rise to 2NH3. So what is Kc written for this? Kc is equal to, let me take it as K1. K1 is equal to NH3 concentration power 2 by N2 concentration H2 concentration power 3, which is given as how much? 2 into 10 power minus 2 liter square per mole square. Okay, this is given, but what is asked? You are asked for this equation. What equation? 2NH3 gives rise to N2 plus 3H2. Do you find a difference here? See, are you finding any difference in writing the mode of this equation? Yes, we are finding some change in mode of writing this equation. The equation for which we have to calculate equilibrium constant is reverse to that of originally given equation. Then let us write K2. K2 is equal to N2 concentration into H2 concentration power 3 by NH3 concentration power 2. See, this is reverse to that of first K1. Before we have discussed here at the bottom. Are you finding that? Then what will be the relation between K2 and K1? Simply K2 is equal to 1 by K1. Okay, if you divide, if you write 1 by K1, then automatically you get K2. Write it, then you will get automatically K2. So that is equal to 1 by K1 given how much? 2 into 10 power minus 2 liter square per mole square. That is equal to what answer you will get? 1 by 10 power 2, 10 power 2 by 2, that is equal to 100 by 2, that is equal to 50. 50. Now you get mole square per liter square, because 1 by K. Here K1 is in the denominator position. Here we are having a liter square per mole square. When it comes up, automatically the units become mole square per liter square. Okay, so that's the answer. Understood? It's very simple. So when you change the mode of writing the equation, automatically equilibrium constant changes. Right? So let us see another one. Here is given the Kc of the resultant equilibrium constant is obtained by adding two equilibrium reactions to the product of two individual equilibrium constants. What is the meaning of this? For the reaction A gives to B, let us write K1 for this. K1 is equal to concentration of B by concentration of A. Simple, right? Then for another reaction, B gives rise to C. K2, let us write K2 is product concentration by reactant concentration. This already we know. In the previous lecture, we have discussed about equilibrium constants. How to write equilibrium constant? Equilibrium constant is equal to product concentration by reactant concentration. Right? Next, A to C. This K3. Right? K3 is equilibrium constant for third reaction. A to C. Then what do I write? C concentration by A concentration. Then what is the relation between K1, K2, K3? The relation, I can write it as K3 is equal to K1 into K2. K1 into K2. So K3 is C concentration by A concentration is equal to K1 is, what is K1? B concentration by A concentration into K2 is C concentration by B concentration. So cancel. Okay. Then again we got C by A. What we want to C by A? Understood? Very simple thing. Okay. So for this equation, Kc is equal to K1 into K2. That is was asked here in the form of a question. Let us see that question. What is that? Here, what is given? H2SO3 gives you H plus plus HSO3 minus. Let us write K1. Let us take it as K1. K1 is equal to H plus ion concentration into HSO3 minus concentration by H2SO3 concentration, which is given as how much? 2 into 10 power minus 2. Okay. So this is one equation. The next equation, what is given? Let us see. The next equation given to us is HSO3 minus gives you H plus plus SO3 2 minus this one. Okay. Let us write, let us consider it as K2 and write it, what is that? H plus ion concentration into SO3 2 minus concentration by HSO3 concentration. Okay. This is given as how much? This is given as how much? 6 into 10 power minus 8. Okay. Now asked is, what is asked? This one is asked, right? Well, asked is H2SO4 gives rise to 2H plus SO3 2 minus. Then right, let us take it as K3. K3 can be written as H plus ion concentration square SO3 minus 2 concentration by H2SO3 concentration. This is how much value, numerical value. From these three, I can write as K3 is equal to K1 into K2. Am I getting that or not? Let us see. H plus ion concentration square into SO3 minus 2 concentration by, what is that? H2SO3 concentration is equal to K1. What is K1? Already we have written that it is H plus ion concentration into HSO3 minus ion concentration by H2SO3 concentration into K2. K2 we have written that H plus ion concentration SO3 minus 2 concentration by HSO3 minus 2 HSO3 minus concentration. Okay. Now HSO3 minus cancel. Then what do you get? H plus ion into H plus ion square. Then SO3 minus 2 concentration by H2SO3 concentration. Yes, I got same. What K3? H plus ion square SO3 minus 2 H2SO3. The same we got on multiplying K1 into K2. Right? We got it. So I can write it as K3 is equal to K1 into K2. That is equal to K1 is 2 into 10 power minus 2 into K3, K2 is equal to 6 into 10 power minus 8. Then what do I get? 2, 6, 12. 12 into 10 power minus 2 plus 8 minus 10. K3. So that is the answer. Simply multiply K1 into K2. Understood? So very simple things. These are very simple things. You need to understand that. That's it. Okay. So let us see. Now, two things we have discussed. Equilibrium constant depends upon temperature, we have discussed. Equilibrium constant depends upon mode of writing the reversible reaction, we have seen. Now, equilibrium constant depends upon stoichiometric coefficients. That is what we are seeing. That is what we are discussing. Right? Here, let us see. A gives rise to B. Okay. Let me write it as Kc1 or K1. K1 is equal to concentration of B by concentration of C. Okay. If I write it as 2A gives rise to 2B, 2A gives rise to 2B. Okay. Now let us see. What did I change here? Mode of writing the equation I did not change. Here also in the first reaction A to B, in the second reaction also A to B. But what was changed is the stoichiometric coefficients has been changed. 2A gives rise to 2B. Okay, then I am writing it as K2. K2 is equal to concentration of B square by concentration of C square. Okay, concentration of B power 2 by concentration of C power 2. Then what is the relation between K2 and K1? Are they both same? No, they are not same. They are changed. Why they are changed? We have changed the stoichiometric coefficients. As we have changed the stoichiometric coefficient, they were changed. Okay. Now what is the relation between K2 and K1? K2 is equal to K1 square. So let us write what is that? B square by C square is K2. K1 is B by C. On squaring it, what do you get? 2. That's it. You got it. So the relation between K2 and K1 is K2 is equal to K1 square. Okay. Right. General format I can write. What is that general format? Right. If A to B, see, A to B, if it is Kc is equal to K and Na gives rise to Nb, then for this Kc is equal to K power N. Before we have seen 2. When you write 2, then what did we write? K1 power 2. Here I am writing N. N moles of A gives rise to N moles of B. Then automatically, what is this? K power N. If it is 3, if I write 3A gives rise to 3B, then what you write for this Kc is equal to K power 3. Because already K is A gives rise to B. Okay. Understood? Understood? Yes, understood. Right. Let us go with another one. A gives rise to B. Let me write K1 is equal to concentration of B by concentration of A. Okay. Now if I give you half A gives rise to half B, then K2 will be written as B concentration B power 1 by 2, A concentration power 1 by 2. Okay. Then what is the relation between K2 and K1? Are they both equal? Are they both same? No, they are not same. Then what makes the relation between them? So I can write it as K2 is equal to root K1, or I can write it as K1 power 1 by 2. Both are same. Both are same. See what I can write? B power 1 by 2 by A power 1 by 2 is equal to B power A. If I whole 1 by 2, the same we get. Are you getting this? Okay. So that is the relation. when you change the coefficients, automatically what changes? Equilibrium constant changes. That is stoichiometric coefficients. This 3, this 2, this half. What are those stoichiometric coefficients? On changing the stoichiometric coefficients, what changes? Equilibrium constant changes. Right? Next, let us go with a question. What question is given? Let us see that. An equation is given. What is that? H2 plus I2 gives 2HI. So what do you write? K1, let us take it as K1, HI concentration power 2 by H2 concentration into I2 concentration, which is given as 49. You are asked this equation. Okay, what is this? Half H2 plus half I2 gives HI. What was changed? Looking first equation and second equation, what has been changed? The change, what change do you observe here? The change observed is mode of writing the equation. Okay. In the first equation, H2 plus I2 gives rise to 2HI. In the second equation also, H2 plus I2 gives rise to HI. But what is the change? Mode, stoichiometric coefficients has been changed. Mode of writing equation is same. What has been changed? Only stoichiometric coefficients has been changed. Okay. So now what will be K2? K2 is HI concentration by H2 concentration power 1 by 2 and I2 concentration power 1 by 2. So what is the relation between K2 and K1? If you square root K1, then we get K2. Square root K1. K2 is equal to root K1. Root K1. So K1 is what? HI power 2 by H2 I2. So power 1 by 2. Then automatically what do you get? HI by H2 power 1 by 2, I2 power 1 by 2. So K2 is equal to root K1. How much given already? 49. Root 49 is equal to 7. So solve. So this type of simple questions are asked in the competitive examinations. The main thing is that you need to understand the concept very well. Listen to the class carefully, understand it. Once you understand it, then you can solve whatever the type of question is given. The thing is that you need to pay concentration. Hope so you understood this session very well. Right? We shall meet in the next session with a new topic. Until then, thank you for watching. Right. We shall meet in the next session with a new topic. Right.